Hi everybody, Mrs. Pesic here. We are looking at section 5.2 on verifying trig identities. Your learning objective is to verify trigonometric identities. A conditional equation is a statement that is true only for some values in the domain. For example, cosine x equals 1/2 would be a conditional equation because this is only true for certain values of x, like for example pi over 3. Okay, but it doesn't work for pi over 6, doesn't work for 0, and so on. An identity is true for all real values in the domain. So for example, sine squared x is always going to equal 1 minus cosine squared x. It's true all the time, no matter what x value you plug in. So there are guidelines for verifying trig identities on page 382. But I want you to remember that if you are trying to verify an identity, you cannot treat it like a regular equation. You cannot add the same thing to both sides. You cannot multiply both sides by the same thing because you don't know that it's a true equation yet. You're trying to prove that it's true. And all of these examples that we're going to be doing are on the 5.2 gift. So if you have not, if you don't have that in front of you, please print it out or pull it out and go ahead and start working with me on these. So for number 1, you're going to verify sine squared theta plus cosine squared theta over cosine squared secant squared is equal to 1. So one of the strategies is to always choose the more complicated side. So in this case, that would be the left side. And I hope that you're noticing that sine squared plus cosine squared is on one side of your flashcards and that that's equal to 1. So we can rewrite this as 1 over cosine squared theta secant squared theta. Now I want you to keep the other side going the entire time you're verifying. Okay? So far we have this. And I think now we could say, well, I know that secant squared would be the same as 1 over cosine squared. So I could write this as 1 over cosine squared theta. And then I'm replacing this secant squared with 1 over cosine squared theta. I'm using the identity that secant is 1 over cosine. Again, I want to keep the right side going. And now I can say, well, this is really cosine squared over 1. So this cosine squared here divides out with this cosine squared. So I really end up with 1 equals 1. And I'm done. I showed that the left side could be simplified all the way down to get us equal to the right side. Let's take a look at number 2. We are verifying that 1 over 1 minus cosine beta plus 1 over 1 plus cosine beta is equal to 2 cosecant squared beta. So in this case, we probably are going to work with the left side because that looks like the more complicated side. So in this case, we have to add these two fractions, but they do not have a common denominator. The least common denominator here is going to be 1 minus cosine beta times 1 plus cosine beta. So that means I'm going to have to multiply this fraction by something in order to get that, and I'm going to have to multiply this fraction by something to get that. All right, so in this first case, we're going to have to probably multiply by 1 plus cosine beta over 1 plus cosine beta. And over here, we're going to have to multiply by 1 minus cosine beta over 1 minus cosine beta. So I now have 1 plus cosine beta over my common denominator. And then I kind of lost that plus sign, but there's a plus in between these two. So I'm going to say plus. And over here on this fraction, I've got 1 minus cosine beta over that common denominator. And I want to show what the right side is because I'm still trying to show that this is equal to 2 cosecant squared beta. Now that I have common denominators, I can combine these fractions and I get 1 plus cosine beta plus 1 minus cosine beta over my common denominator. And again, I'm going to keep writing the other side of the identity until I get the two sides to be equal. I think here we can see that the cosine betas are going to subtract off in the numerator. So I'm left with 2 in the numerator. And if we multiply this out using FOIL down here, I think we'll have 1 plus cosine beta minus cosine beta, and then minus cosine squared beta. Again, we're trying to show that this is equal to 2 cosecant squared beta. And now these cosine betas are going to subtract off. So we get 2 over 1 minus cosine squared beta. Trying to show that that's equal to 2 cosecant squared beta. Again, if you see a 1 and a cosine squared or a 1 and a sine squared, chances are you can simplify by rewriting the 1 as sine squared plus cosine squared. So let's replace this one with sine squared beta plus cosine squared beta. And then I still have this minus cosine squared beta. And again, I'm trying to show it's equal to 2 cosecant squared beta. At this point, the cosine squared betas are going to subtract off. So I have 2 over sine squared beta equaling 2 cosecant squared beta. And really, the sine squared beta is the same as 1 over cosecant squared beta. So I can replace the sine squared with 1 over cosecant squared. I think I said that wrong before. Sine squared is 1 over cosecant squared. And so that is, I think, going to bring us the rest of the way home, because if we multiply by the reciprocal, we'll get 2 cosecant squared beta on both sides of this identity. So we showed that we can simplify the left side until it is equal to the right side, and we're done. Notice we're baby stepping everything. Baby steps, baby steps. Let's take a look at number 3. We're going to verify that secant squared x minus 1 times sine squared x minus 1 is equal to negative sine squared x. Again, I would start with the more complicated side. And I think you could probably FOIL on the left side, and that'll work fine. But let's try to rewrite using like this 1 is sine squared plus cosine squared. So we can write sine squared x minus the quantity sine squared x plus cosine squared x, right? And then with secant squared x minus 1, don't we have an identity that 1 plus tangent squared is equal to secant squared? So I can really rewrite that. Secant squared x, I want to replace this 1 here. I'm going to replace with 1 plus tangent squared equals, let's do this. Instead of replacing that 1, since we know secant squared is equal to 1 plus tangent squared, let's take out the secant squared and replace it with that. So we're going to say 1 plus tangent squared, okay? And then we still had the minus 1, right? So it looks like this. So I replace the secant squared with 1 plus tangent squared, and I replace this 1 over here with sine squared plus cosine squared. Again, we're trying to show that this is equal to negative sine squared x. Over here, the 1's are subtracting off, so I just get tangent squared x. Over here, I'm going to distribute the negatives, so I get sine squared x minus sine squared x minus cosine squared x. Again, keep the right side going, and we see here that the sine squareds are subtracting off. So I've got tangent squared x times a negative cosine squared x, and we're wondering, is that equal to negative sine squared x? I would rewrite tangent squared as sine squared x over cosine squared x, and I'm multiplying that by negative cosine squared x, or I can think of that as negative cosine squared x over 1, and I'm trying to show that it's equal to negative sine squared x. The cosine squareds are dividing out, so I really get this negative, think of it as negative 1 times sine squared. So I get negative sine squared x equaling negative sine squared x. We've shown that the left side can be simplified down to be the right side. Let's take a look at the next one. We're verifying this identity. Cosecant x minus sine x equals cosine x cotangent x. I think that the subtraction side is going to be the more complicated side, so I would probably rewrite this maybe as 1 over sine x minus sine x over 1, right? Because sine x is the same as sine x over 1. And I'm trying to show that it's equal to cosine x cotangent x. If you have two things being added or subtracted, chances are you want to get a common denominator. So in this case, I would probably multiply this fraction by sine x over sine x. And if I do that, I get 1 over sine x minus sine squared x over sine x. And I want to show that that is equal to cosine x cotangent x. Common denominators now, so I can rewrite this as 1 minus sine squared x over sine x. Keep that right side going. I would replace that 1 with what? Sine squared plus cosine squared. So I get sine squared x plus cosine squared x minus sine squared x over sine x is equal to cosine x cotangent x. And so when I do this, I get sine squareds dividing out. And so I'm left with cosine squared x over sine x equals cosine x cotangent x. At this point, I would rewrite the cosine squared as cosine x times cosine x over sine x. And maybe you see the light at the end of the tunnel here, but we probably want to rewrite this as cosine x over 1 times cosine x over sine x. I think that's equivalent to the line above. And because cosine x over sine x is equal to cotangent of x, we will just be finished with this problem. So we got the left side to equal the right side. All right, there is more than one way to do these problems, but I'm just showing you one possible way for these. Let's take a look at this one. Verify the identity. Cosecant x plus cotangent x equals sine x over 1 minus cosine. And the hint is, really the right side is the more complicated side. Okay, so for this problem, my suggestion on this, and this is kind of like a strategy or a trick that you can use, if you've got two things in the denominator and you don't want two things in the denominator, to get rid of that, you probably want to multiply by, instead of 1 plus cosine x, let's multiply top and bottom by 1 plus cosine x. If we do that, something nice is going to happen over here on the right side of this equation. So let me leave this as sine x times 1 plus cosine x in my numerator. And using FOIL in the denominator here, I'm going to have 1 plus cosine x minus cosine x minus cosine squared x. And again, I'm trying to show that it's equal to cosecant x plus cotangent x. The cosine x's are subtracting off here, so I have sine x times 1 plus cosine x over 1 minus cosine squared x. Again, trying to show it's equal to cosecant x plus cotangent x, so keep that left side going as we're simplifying the right side. Okay, what is 1 minus cosine squared? Well, we can replace this 1 here with sine squared plus cosine squared. So I'll have sine x times 1 plus cosine x over sine squared x plus cosine squared x minus cosine squared x. Again, trying to show that this is equal to cosecant x plus cotangent x. And in this case, the cosine squareds are going to subtract off. And so now I have sine x times 1 plus cosine x over sine squared x. And I'm trying to show that that's equal to cosecant x plus cotangent x. I think it's okay to say this sine x here is going to divide out with one of those sine x's there. And so now I have 1 plus cosine x over just sine x. And we're trying to show it's equal to cosecant x plus cotangent x. So now on this right side, I can rewrite this as 1 over sine x plus cosine x over sine x. That's allowed, splitting this up into like two separate fractions here. And we're, again, still trying to show this equal to cosecant x plus cotangent x, but 1 over sine is cosecant x, and cosine over sine is cotangent x. So we have successfully showed that the right side, in this case, can be simplified down to the left side. Again, baby stepping everything. Baby steps for everything. All right, let's take a look at this one, number 6. We are verifying this identity. Which side looks like the more complicated side? I would say the left side here. Can we divide out this cosine x here with this cosine x? That would be a no, right? Because the cosine in the numerator is a term, not a factor. So I just want to remind you of that. I think if we try to do our strategy, and there's lots of different ways to go here, but if we replace, what do I want to do? I think I would replace, no, let's multiply top and bottom, like we did in the last example. Let's multiply by 1 minus secant x over 1 minus secant x. Because if we got two things in the denominator, I think that's a pretty good strategy. So in this case, we're going to have 1 minus secant x times tangent squared over 1 minus secant x times 1 plus secant x. And we're trying to show that's equal to 1 minus cosine x over cosine x. All right, in this case, if we do FOIL down here, something good should happen. So in our numerator, we still have 1 minus secant x times tangent squared x. And in the denominator, 1 plus secant x minus secant x minus secant squared x. And again, still trying to show this is equal to 1 minus cosine x over cosine x. Over here, the secant x's are subtracting off, so we get 1 minus secant x times tangent squared x over 1 minus secant squared x. Keep that right side going. I think when we see, if we see a 1 and a secant squared together, we might want to replace this 1 with, it's 1 plus tangent squared equals secant squared. So how about we replace secant squared with 1 plus tangent squared? So if we do that, we're going to have 1 minus secant x tangent squared x. And in the denominator, we're going to have 1 minus, and we're replacing secant squared with 1 plus tangent squared. Still trying to show that this is 1 minus cosine x over cosine x. If we distribute this negative here, we're going to have 1 minus secant x times tangent squared x over 1 minus tangent squared x, which we're trying to show is equal to 1 minus cosine x over cosine x. The 1's are subtracting off here, so we get 1 minus secant x times tangent squared x over negative tangent squared x. Still trying to show this is equal to 1 minus cosine x over cosine x. I think that we can divide out this tangent squared with this tangent squared. And so that's really going to give us 1 minus secant x over negative 1. And we're trying to show that's equal to 1 minus cosine x over cosine x. And if it's 1 minus secant over negative 1, wouldn't that be the same as just secant x minus 1, right? Because it'd be 1 over negative 1 is a negative 1. Negative secant over negative 1 is going to be positive secant. So that's going to, we're trying to show that's equal to 1 minus cosine x over cosine x. And I think it's okay at this point if you want to switch and say, you know what, I've simplified that left side about as much as I can. Let's try and simplify the right side. So we can split up the right side into like 1 over cosine x minus cosine x over cosine x. And so in this case, we get 1 over cosine is secant x, and cosine over cosine is 1. So we have shown that the left side and the right side are equivalent. We've simplified the left side and simplified the right side until they are equal to each other. And so that was done. All right, so there are two examples from calculus. In calculus, it's sometimes useful to be able to take the simpler side and transform it into the more complicated side. So for this example, number 7, tangent cubed x equals tangent x secant squared x minus tangent x. But if we want to take the simpler side, that would be the left side here. We may want to split up the tangent cubed into tangent x times tangent squared x. And if we've done that, then our next step could be to rewrite tangent squared as secant squared x minus 1. And then we can distribute that tangent x to both of those, and we'll have the same thing on both sides. So we'll have tangent x secant squared x minus tangent x equals tangent x secant squared x minus tangent x. All right, let's take a look at one more. Again, let's try and work on the simpler side first. So if I've got cosine cubed x times sine to the 4th of x equals the quantity sine to the 4th x minus sine to the 6th x times cosine x. If I'm going to transform the left side, I notice that on the right side I just have this one cosine x all by itself, kind of factored out. So I might want to do the same thing on the left side, just factor out a cosine x by itself. So there's my cosine x by itself, and that leaves me with cosine squared here. So I split up the cosine cubed. And now we can rewrite this left side by rewriting cosine squared as 1 minus sine squared. And then that's 1 minus sine squared times sine to the 4th is equal to cosine, or times cosine. And then if we distribute the sine to the 4th times both of these, we should have the left side equaling the right side. So we'll have sine to the 4th x minus sine to the 6th x, that quantity times cosine x on both sides. Okay, so that completes the lesson for 5.2. Thanks for watching.